So in relating linear expansivity with cubic expansivity, so we are going to follow the same method we used during our expansivity. So it's just to multiply out and then we have our results. So here, the cubic expansivity is the increase in volume per unit volume per degree rise in temperature. So which is this V1, V2 minus V1 all over V1 bracket change in theta. Okay, so this means that V2 minus V1 is equal to is cross multiplying. We have V1 bracket theta. So but theta 2 minus theta 1 is equal to change in theta. Okay, so we now have that V2 is going to be V1 plus gamma V1, then change in theta. So V2 here is now going to be V1 bracket 1 plus gamma here change in theta. So this is going to be our first expressions. So deriving that from the linear expansivity. So we already saw that V1 is equal to L1 B1 H1, and then V2 is equal to L2 B2 H2. Okay, so these are volume, length times breadth times height. Okay, so looking for this now, so we now have that V2 is equal to L2, which is this L1 plus L1 bracket 1 plus alpha change in theta, okay, multiplied by B2, which is this B1 bracket 1 plus alpha change in theta, okay, multiplied by H2, which is H1 bracket 1 plus alpha change in theta. So this is, so opening the bracket, we have that V2 equal to L1 B1 H1. Open bracket, 1 times 1 is 1. 1 times alpha change in theta is alpha change in theta. Then alpha change in theta times alpha change in theta, we have alpha change in theta. Then alpha change in theta times alpha change in theta, we have alpha square change in theta square. Okay, so this is what we have. So we are multiplying the first section. So we are multiplying this and this. Okay, so from our final results initially, we have that this L1 L2 L1 B1 B2 is equal to V1. The open bracket. Then this is now going to be alpha plus 2 alpha change in theta, then plus what? Alpha square change in theta square. Close bracket. Then multiplying it with this now. So which is now 1 plus alpha change in theta. Okay. Opening the bracket, then we have V2 is equal to V1, open bracket, 1 times 1 is 1, then 1 times 2 alpha change in theta, 2 alpha change in theta, plus 1 times alpha squared change in theta square, okay, plus alpha change in theta times 1 is alpha change in theta, then alpha change in theta times 2 alpha change in theta is going to give 2 alpha square change in theta square, and then plus alpha cube change in theta cube. Okay, so this is the final result here. So V2 here is now going to be V1, then bracket 1, then alpha change in theta plus 2 alpha change in theta plus alpha change in theta will give 3 alpha change in theta, then alpha squared change in theta, and then this will give equally 3 alpha squared change in theta square, then plus alpha cube change in theta cube. Okay, so already we have stated that linear expansivity is too small. So, and when it is expanded or squared, they become insignificant. So this is going to be insignificant because they have no values here. So we have V2 is equal to V1 bracket 1 plus 3 alpha change in theta. Okay, so and this is going to be our equation 2 here. So relating that with this, we now have that V2 here is equal to V1 bracket 1 plus gamma change in theta. Okay, so this is our equation 1. So relating the two equations, we have it, we can only see that gamma here is equal to 3 alpha. So you can see that cubic expansivity is equal to 3 times linear